Hello viewers, welcome to online math learning program. I am Anul Haq. Today we will discuss the first exercise of the lesson named the story of geometric shapes. On the last session, we knew the solution of the question number 1 and 2. Now, in this session, we will explain the solution of the question number 3, 4 and 5. Okay, let's start the question number 3. The stem says, in the diagram, the perimeter of the parallelogram field is 180 meter. The area of the parallelogram can be obtained in more than one way. The first question A is, find the area of the parallelogram in more than one way with logical explanation. The second question B says, show that the area of the parallelogram field equal twice the area of the triangle ABD. On the figure of the stem, the length of the big side of the parallelogram ABCD is 2 into a meter and the length of the small side of the parallelogram is a meter. In case of parallelogram, we know that both the opposite sides are equal and parallel. And if we suppose AB is the base of the parallelogram ABCD, then DF will be definitely the height of the parallelogram and the length of the height DF is 5 meter. So we can start the solution such like that. In the diagram, the perimeter of the parallelogram field is 180 meter. We know that the perimeter is the total outer length of the parallelogram or summation of the all sides of the parallelogram. So A plus 2A plus A plus 2A equal 180. And after calculating it, we find that the value of A is 30 meter. Now we have to determine the area of the parallelogram in different methods. Method 1. Applying the formula of the determining the area of the parallelogram. So there is a formula of determining the area of parallelogram. It is a common formula. The area of a parallelogram is the product of the length of its base and height. Here the base is 2 meter. Here AB is the base, or we can say DC or CD is the base, and the height is 5 meter. Here in the figure, DF or FD is height of the parameter of the parallelogram. So DF is 5 meter. So the area of the parallelogram is 2A into 5. And after calculating it, we find the value of the area of the parallelogram is 300 square meter. So it is one method. Now we will explain the method 2. And before starting the method 2, we just pay our attention in the figure. In the figure, we see there is a hypotenuse BD which divides the parallelogram ABCD into two triangles. There are ABD, triangle ABD, and another triangle is BCD. So we can start like that, adding the values of two congruent triangles after finding the areas of them formed by the hypotenuse of the parallelogram. So there is a word congruent. congruent triangles. The congruent means both triangles are same size. Both triangles are same size and same shaped. One shape can be repositioned or flipped to coincide with other shape. So the hypotenuse BD divides the parallelogram into two congruent triangles, uh, triangle ABD and triangle BCD. Thus, the area of the parallelogram equal equals the sum of the areas of the two congruent triangles. So the area of triangle AVD equal half into base into height. We say the base is 2 into a meter and height is 5 meter. So the area of the triangle ABD is equal 5a square meter. On the other hand, the area of the triangle VCD equal half into base into height. Same formula. Here base is also 2a meter and height is also 5 meter. So the area of the triangle VCD is 5a square meter. We see that both the triangles have the same amount of area, 5a square meter. Triangle ABD 5a square meter, triangle BCD 5a square meter. So they are really congruent. So the area of the parallelogram ABCD is equal the area of triangle ABD plus the area of triangle BCD. So 5a plus 5a equal 10a square meter, and after inputting the value of a 30, we find that the area of the parallelogram ABCD is 300 square meter. So we explain the two way of finding the area of the parallelogram. So we can go to the second question B. In the second question, we have to show that the area of the parallelogram field equal twice the area of the triangle ABD. So you can start like that. The hypotenuse BD divides the parallelogram ABCD into two triangles, triangle ABD and triangle VCD. In between triangle ABD and triangle VCD, we find that side AB, side AD equal side BC because the value of both sides individually is a meter. And side AB is equal side CD equal to a meter because both of the sides individually is equal to a meter. And hypotenuse BD is a common side for both the triangles. So we can say the triangle AVD is congruent with triangle VCD. Here congruent is both the triangles are same sized and same shaped. So triangle ABD is equal to triangle VCD. On the other hand, the parallelogram ABCD is equal triangle ABD plus triangle VCD, because as hypotenuse BD divides the parallelogram ABCD into two triangles. So if we add these two triangles, we can find the area of the parallelogram ABCD. So triangle ABD plus triangle BCD is equal to the parallelogram ABCD. After that, triangle ABD plus triangle ABD. Here we know that triangle ABD is equal to triangle BCD, so we can substitute the value of triangle BCD by triangle ABD, as because triangle ABD is equal to triangle BCD. So after adding triangle ABD and triangle ABD, we find 2 into triangle ABD. So the parallelogram ABCD is equal 2 into triangle ABD, or twice the area of triangle ABD. And by this we can prove it or show that the area of the parallelogram field equal twice the area of the triangle ABD. Okay, the next question is 4. The question says the length of the floor of a room is 26 meter and the width is 20 meter. How many mats of length 4 meter and width 2.5 meter will cover the whole floor? What will be the total cost of each mat? Cost taka 45. So to solve the question, at first we have to multiply the 26 with 20 to determine the area of the room, and then we have to multiply the digit or number 4 with the number 2.5 to determine the area of mat. And after determining the area of both room and mat, we have to divide the area of the room by the area of mat, and after that we will find the number of total mat, and then we will multiply the number of total mat with the digit 45, because it is the value of each mat cost, and then we will determine the total cost of all mat. So we can start like that. The length and the width of a room are 26 meter and 20 meter respectively. So the area of that room is 26 into 20 equal 520 square meter. Again, the length and the width of a mat are 4 meter and 2.5 meter respectively. So the area of a mat is 4 into 25 equal 10 square meter. So the number of the mats to cover the whole floor is 520 divided by 10 equal 52. So 52 is the total number of the mats. Now we have to multiply the each mat cost taka 45 with the digit 52 or below 52. So total cost will be 52 into 45 equal taka 2340. So 2340 is the total cost of all mats. So we can start question number 5. Here there is a stem with figure, and the figure says ABC is a triangle, and in this triangle AB, the length of AB is 100 centimeter, length of AC is 120 centimeter, and length of BD is 80 centimeter, and VD is vertical on AC. And then what is the length of CE, where CE is vertical on AB. So we have to determine the length of CE. Here this small box is the sign of right angle, so BD is perpendicular to AC and CE is perpendicular to AB. Okay, we can start like that. In the figure, AB is 100 centimeter, AC is 120 meter, 120 centimeter, BD is 80 centimeter, and CE is what? So when the base and height of the triangle ABC are AC and BD respectively, then the area of triangle ABC is half into AC into BD, as we know that the area of triangle, the formula of the area of triangle is half into base into height. So after calculating, we find that the area of triangle ABC is 4800 square centimeter. So if we pay attention to the figure, if the base of triangle ABC is AC, if the base is AC, then the height of the triangle will be BD. So the area of triangle ABC is half into AC into BD, where AC is base and BD is the height. Again, if we change the base, then height will also be changed. So if we say that if the base is AB of the triangle ABC, then the height will be C. So the formula will the value of the uh, formula will be changed. So then the area of triangle ABC will be half into AB into CE. So as we change the base and height of the triangle ABC, then the value of area of triangle ABC will also change. So after calculating it, we find the area of the area of the area of the triangle ABC is 50 CE square meter. So we can say by condition 50 CE is equal 4000 4800, or CE equal 4800 divided by 50, and then the value of CE will be 96 centimeter. After calculating, we find that the value of CE is 96 centimeter. So we can say the length of CE is 96 centimeter. So you can see the solution at a glance. So you can see the solution at a glance again. Okay, thank you everybody to participate today's session.